Hi, I'm Luke Linzinger, and I'm taking computer science software engineering as a part of this career and technical education program at Gull Lake High School. In today's vlog, I will be installing a Linux and Ubuntu and virtual machine using Oracle's VirtualBox Hypervisor 2 software. To first determine your system's information, go to the Windows key and type in system information. Once there, you can see what your CPU is, which should be under processor, and you can also find your RAM amount. In this PC, there's 32 gigabytes of RAM. You can also find your hardware service resources, including your storage. Your hard drive can be found under components and then storage and drives. On this PC, there's around 1 terabyte of storage. This is my file management for Linux and Ubuntu. Here's the ISO. You can find this free online on Linux because it is an open source and they let us mess around with it for fun and free. Now I'm going to make a new folder for my practice vlog virtual machine. We'll name it vlog VM. Now it's time to create the virtual machine. We'll maximize Oracle VirtualBox, click on Tools, and then click New. Once here, we can name it vlog VM. We can change the folder, go Other, Desktop, and then go to CSSE, Virtual Machines, Linux and Ubuntu, and Vlog VM. Select that folder. Then for ISO, we can go to Other and select it. Once done with that, you can click Next. I'm going to keep the username the same, but change the password to a much simpler one for the video. Linux doesn't like capitals or spaces, so we'll just change this to all lowercase, vlog VM, no space. Once you click Next, you have to choose the amount of RAM you want. For this virtual machine, I want to use 8,100 megabytes, which is 8 gigabytes. I also want to change the amount of cores this virtual machine uses to 3. Next, you want to make the amount of storage the virtual machine uses. I'm going to put this at 25, which it already is at, and you do not want to pre-allocate the storage, otherwise they'll be bad. Once you click Next again, you get to your final site, which you review the information and click Finish. It is now a virtual machine, and it is powering up to install. While this installs, I will share some information about system stuff. Now I'll teach you about hypervisors while this finishes installing. Hypervisors are software or hardware platforms that enable the creation of management of virtual machines. They allow multiple operating systems to run on a single physical machine simultaneously by abstracting the hardware resources. Hypervisors are a core component of virtualization technology. There's Type 1 and Type 2. Type 1 is a bare metal hypervisor. It runs directly, it offers better performance, and is commonly used in data centers and enterprise environments. Some examples of this are VMware, Microsoft Hyper-V, Xen, and KVM. Type 2 is a hosted hypervisor. They run on top of the host operating system. They're easier to set up and typically used for testing. And some examples of this are VMware, Workstation, Oracle VirtualBox, and Parallels Desktop. Key function of hypervisors. They resource allocation, isolation, hardware emulation, snapshots, and migration. Some benefits of using hypervisors is efficient resource utilization, flexibility, cost savings, disaster recovery, and backups. Hypervisors play a critical role in cloud computing, server virtualization, and even gaming or development environments where multiple OSs need to coexist. Now about computer hardware. The CPU is a primary component of a computer that performs most of its processing tasks. It is often referred to as the brain of the computer because it executes instructions from programs and processes data to perform computations. Key functions of a CPU is fetch, decode, and execute. Components of a CPU include control unit, arithmetic logic unit, registers, and cache. Characteristics of the CPU are clock speed, core count, threads, architecture, and the thermal design power. There are also different types of CPUs: desktop CPUs, mobile CPUs, server CPUs, and embedded CPUs. Some common manufacturers of CPUs are Intel, AMD, ARM. They also play a major role in modern systems. The CPU is essential to system performance but works in conjunction with other components such as RAM, storage, and the GPU to deliver a complete computing experience. Its performance impacts everything from running basic applications to extensive tasks like gaming, video editing, and scientific simulations. And this is a picture of an Intel Core CPU. The next piece of hardware is RAM. RAM is random access memory, and it's a type of computer memory that stores data and instructions temporarily while a system is running. It is a volatile memory, meaning this data is erased when the computer is powered off. RAM is essential for multitasking and overall system performance. Some key features of this is it's temporary, it's volatile, and it's random access, so any of it can be accessed directly and nearly instantly, unlike sequential storage. RAM works by data loading, it's temporary, and it's clearing when a task is done. There are two types of RAM: dynamic and static. RAM specifications include capacity, speed, form factor, and channels, and it plays a big role in performance with multitasking, gaming, and productivity. Some common misconceptions include more RAM equals better performance, which does not always mean such the case, and RAM replaces storage, which is also not true. And this is what RAM could look like. HDD, or hard disk drive, is a type of data storage device used in computers and other electronic systems. It stores digital data persistently even when the computer is powered off. HDDs use magnetic storage technology to write and retrieve data on spinning disks known as platters. Some key components of HDD are platters, read-write head, accutor arm, spindle, and controller. They work by writing data, reading the data, and then they also access the data. Some advantages of HDD is high storage capacity, durability for cold storage, and affordability. Some disadvantages are slower performance, higher power consumption, and mechanical wear and tear. Some specifications of HDD include capacity, speed, form factor, and interface. Use cases for HDDs: bulk storage, data archiving, and budget-friendly systems are all places you would use HDDs. And this is what one could look like. HDDs are still widely used for bulk storage and backups, although SSDs are becoming more popular due to their speed and reliability. Many systems combine both in a hybrid setup to balance performance and storage capacity. And now our virtual machine is done loading, so I'm going to go ahead and full screen this and log in. And you can see that this is just like any old computer. You can go to the internet, Firefox web browser, search anything, look at the news. You can do anything you want on here. And you can also, while this is open, just go to your normal desktop and also use your host computer as well at the same time. That's about it for today's vlog. Thank you for your time, and hopefully you learned something new.